Hi everyone, my name is Madison Smith and this is my Lab 1 report video. So to start, to introduce the purpose of the lab was to figure out how different objects interact with one another of different same and neutral charges, to find the net electric charge on a single object, and to calculate the gravitational and electric forces and how they interact with one another using Coulomb's law and Newton's second law. So some key principles that I wanted to point out to start was Newton's first law is that if the forces acting on an object are balanced, then the acceleration of that object is zero. I'll show this in more detail later, but basically when the top tape is suspended motionless above the bottom tape, the acceleration is zero. So that means that the forces acting on the piece of tape are going to be balanced. So Newton's second law says that force equals mass times acceleration. So the acceleration of an object produced by a net force is directly proportional to the magnitude of the net force. So in this case, since the acceleration of the top piece of tape is zero, the net force acting on the top piece of tape is also going to be zero. And Coulomb's law says that like charges will repel and opposite charges will attract with a force proportional to the product of the charges and inversely proportional to the distance between the charges squared. This is a formula that I will use in my calculations later. So some assumptions that I had going into the lab is that the height of the tape would be negligible when I was calculating its area, to treat the tape as a single point charge in the center, and that the charges on both pieces of tape are the same and evenly distributed over the tape, and to ignore air resistance when calculating the forces. And my expectations going into the lab were that like charges would repel, opposite charges would attract, and the two U-tapes would repel one another since they are the same charge, and this is following Coulomb's law. So my observations that I found were exactly as I predicted, that the two U-tapes did repel one another since they had the same charge, and which ended up both being positive. The U-tape in my hand were attracted to one another, as well as with a plastic pen, so that this showed that like charges would repel one another and like charges would attract. And if something is neutral, like the pen or my hand, the charged tape would cause it to polarize, and that the opposite charge to the tape would come to the surface and attract to the tape. So in this case, the negative charges in my hand would come to the surface and attract to the tape. So my free body diagram went along with Newton's first and second law, like I was describing earlier, so that because the top piece of tape was motionless, the electric force from the bottom piece of tape would have the same magnitude as the gravitational force downward, keeping it suspended motionless. So they would have the same magnitude in opposite directions. So my calculations were, I calculated the mass of a single piece of tape and the distance between the two pieces of tape when the top tape began to float. So I calculated the magnitude of the gravitational force and set that equal to the magnitude of the electric force, which I showed before that they would be equal to one another, and was able to do some manipulation and solve for the charge of the top piece of tape. And I also calculated the number of electrons on that single piece of tape using the number of atoms total. So for my computational model, I did this using VPython and calculated the gravitational force downward on the top piece of tape, which is shown by the blue circle, and the electric force on the top piece of tape due to the bottom piece of tape, and those are equal to each other in opposite directions, and the electric charge of the top piece of tape is equal to what I calculated previously, and the net electric force is zero, which goes with my free body diagram as well. So some questions that I wanted to answer is that what if electrons had positive charge and protons had negative charge? So nothing would change in this case. This whole experiment is based on what the charge of different things are and whether they're attracted or not. So again, if they have the same charge, they're going to repel. If they're opposite, they're going to attract. It doesn't really matter which one is assigned to what. And so why is it important to handle the tape as little as possible? So as we've shown in the lab, when you rub your hand against the piece of tape for too long, that the charge on the tape will disperse and spread out onto your hand, so the tape will start to lose its charge and it won't attract anymore. So the main takeaways from this experiment that I found were to understand how two charged objects interact with one another, and that opposite charges attract, like charges repel, and a charged object attracts to a net neutral object, and that if the momentum of a floating object is 0, then the forces acting on it are in opposing directions and equal magnitude. So this really encompassed and explained Newton's first two laws and Coulomb's law in a demonstrative capacity. So thank you so much for listening, and I hope you have a great day.